This video is for Mafuza, who asked a question from the practice exam, chapter 5.5, integral using substitution. So we have an antiderivative here, and we just learned about substitution. So you use substitution when the problem looks ugly, when you can't easily find the antiderivative. So looking at this, we want to ask yourself, what do we let u equal to? So u is going to equal to the ugly part in this problem. So I would recommend looking at this problem, it's this exponent here that looks kind of ugly. So because finding the antiderivative of e to an exponent is okay, but because the exponent is messy looking, that's what I would want to make look simple. So I would let u equal to 1 over x to the 5th, or in other words, x to the negative 5. So whenever you let u equal to something, you always want to find du dx, so the derivative of u, right, with respect to x. So find du dx, so the derivative of this is negative 5x, and you subtract 1 from the exponent, negative 6. In other words, negative 5 over x to the 6th power. And I'm kind of happy because I see this x to the 6th right there. All right, so just to make this look super obvious, du dx is now equal to negative 5 over x to the 6th. All right, so I could bring this dx over to this side. So du is equal to negative 5 over x to the 6th, and the dx right here, there. So reminder, that's the differential. Okay, so I'm going to circle this because I'm going to go back to this later. I might need that. So right now, I'm going to now substitute. So once you find u and du dx, the next step you need to do is now you do your substitution. So when I substitute, I have the integral, and I mentioned in class that there's two ways of doing a definite integral. Either you change the endpoints or you put the star and double star as temporary placeholders. So I'm just going to change it to star and double star since we're going from x to now u. And u does not have the endpoints 1 and 2. It's going to be different endpoints, which for me, I like this method because I don't want to figure out the endpoints right now. So these are temporary placeholders. So here, e 1 over x to the 5th is now e. 1 over x to the 5th is now u. So I'm going to replace that with a u. Okay. And I'm going to just put over x to the 6th right now, just for now, because the goal is to make everything in terms of u, but I want to show you what's going to happen to this x to the 6th. The dx, well, what is dx equal to? Dx is equal to, so let me solve for dx now. So dx is equal to, I'm going to divide this over to the other side. In other words, multiply by the reciprocal. So I'm going to get negative x to the 6th over 5 du. You guys see that? So I divide this to the other side. So when I divide a fraction, I multiply by the reciprocal. So the reciprocal of this is negative x to the 6th over 5. And of course, the negative could be either on top or bottom. It doesn't matter. So this is what dx equals to. So this dx here, I'm going to change the dx now to this. So I'm going to put times negative x to the 6th over 5 du. And notice what happens when you do this. The x to the 6th will cancel out. So you're left with a negative here. So it'll just be a negative 1. So now I'm left with the integral of, I'm just going to pull this negative 1/5 to the front, negative 1/5 e to the u du. So everything is in terms of u now, and to find the antiderivative of e to the u is actually a lot simpler than finding the antiderivative of this ugly thing. So that's the point of u substitution. You're making something that's ugly into something that's a lot more prettier. So now I go ahead and find the antiderivative of the prettier part. So to find the antiderivative of this, we know that the antiderivative of e to the u is just e to the u. So I have negative 1/5 e to the u, and then this is going from star to double star. So in this method I'm using, now I'm going to replace the u with the x terms, right? So this was just a temporary substitution. So now this becomes negative e to the 5th, negative 1/5 e to the u. So u is 1 over x to the 5th. So I'm going to put 1 over x to the 5th. And now that my x is back, I'm going to go back to these endpoints for x is 1 and 2. Alrighty, So now using the fundamental theorem of calculus, so FTOC, fundamental theorem of calculus, you plug in the n point 2 and you plug in the n point 1. So I have negative 1/5 on the outside multiplied by e to the 1 over 2 to the 5th minus e to the 1 over, and if I put 1 here, it'll just be e to the 1 power. All right, so when I do this, 2 to the 5th is e to the 1 over 2 to the 5th is 32 minus e. And that, my friends, is the final answer. And let me just double check with WebAssign. WebAssign had it as, sorry, I'm looking at the message that Mafuza sent me. So it's written as this. So it comes out as positive 1/5 e to this thingamajigger, which is the same thing. If I change this negative 1/5 to positive 1/5, then I basically just change this negative e to a positive e and e to the 1 over 32 to a negative e 1 over 32. And if you want to make it look exactly like WebAssign, it'll be 1/5 e minus the square root of e to the 32 power. Same difference, but I would accept this form, or this form. Let me know if you have any questions.